Hey there, this is Kung Fu Physics, where we are working our way through practice physics GRE problems. The one I have today is the second part of a combination problem. This is number 42, so maybe you've already looked at number 41. I'll give you the problem to you really quick. It's an easy mechanics problem. Hopefully this video is short. But you read the top, and we read this in problem 41. A cylinder with a moment of inertia, 4 kg/m squared, about a fixed axis, initially rotates at 80 radians per second about this axis. A constant torque is applied to slow it down to 40 radians per second. And then 42 is if the cylinder takes 10 seconds to reach the 40 radians per second, the magnitude of the applied torque is. So, I don't know, there may be one way that you can be confused about this, but to me it seems pretty simple. The first thing that popped into my head is the translational equivalent. Force equals mass times acceleration, and then right off the bat I knew we were dealing with the torque here, so this is the way I remember all these rotational formulas. I mean, I remember them, but just in my head I know they're just like the translational equivalents with the substitutions. So a torque equals the moment of inertia multiplied by the angular acceleration. And we want the torque, the applied torque. And so we want this. We know that I is 4, and we can actually get the alpha, which is the angular acceleration, really easily with what they give us in the problem. They say that it starts at 80 radians per second. It's going finally at 40 radians per second. So this is the change in the angular velocity. And how long did it take to make that change? Well, they tell us it took 10 seconds. So I'm leaving all my units all naked there, just saying what they are. But that's what an angular velocity is. Let me write it up here just to be a little more thorough. But I want to use an omega. Omega final minus omega initial divided by like delta t, I guess. Something like that. And that's for a constant angular acceleration, which it says it's a constant torque. So it makes sense it would be a constant angular acceleration. So for constant angular acceleration, this is just the same as a velocity or an acceleration. It also has a translational equivalent, right? Over delta t. That should be really familiar. So anyways, very, very simple problem. You just carry this out here and you get 40 over 10. And you just get 4 times 4. Torque equals 16, whatever those units are on torque. It gives us Newton meters, right? And so we do have an answer there that matches up with 16, and it is answer D. 16 Newton meters. So we got that one. That was really fast. You could really make up some time on these two problems that we just did. I posted 41 separately, but it's also very short. So 41 and 42, very easy mechanics problems. Hopefully, if these were on the physics GRE when you were taking it, you could do them fast and make up some time. So very good. As always, thanks for watching.